Now, we basically have 25 minutes, which I haven't finished the entire sensory system. I will go fast. You will have the videos to basically, if you miss something, you have the videos to go with, okay? Because I'd rather finish the entire lecture instead of not having the entire done, because I'm repeating myself multiple times and telling you to cover it on your own. You have the videos, okay? So if you don't understand something, I'm not going to stop and explain you this. So you make sure that you listen, okay? Okay, so we're going to talk about the sensory system. Can you start the recording? It's already, okay. Stimulus and its components. Okay? Basically, what is a stimulus? It's a sensory input which causes changes within or outside of our body. Okay? So anytime there is changes within our body or outside of our body, basically it stimulates our sensory system, and that is a stimulus. Okay? So if I pinch Jennifer, that is a stimulus because it changed. There's some change occurring. Okay? The stimulus can be physical or chemical in nature. Physical means heat, sound waves, etc. Chemical is odors, which you could find in your food. Okay, odors from your food, odors in you're walking by, you smell stuff, right? So the chemicals can be found in odors. Chemicals can be found in drinks. It could be found in drinks or food. Does that make sense? Okay. Sensation. What is sensation? Sensation is conscious awareness of a stimuli. Therefore, every time we hear a loud sound in the sky, what do you correlate with? That it's thunder, right? But what is perception? Perception is going a step further. It's understanding what that sensation means. So if you hear thunder or if you hear a loud sound, your mind goes, okay, we're going to have a storm on the way, correct? What is example? Okay, you're driving on the car and you hear sirens. What does the sirens tell you? There's cops or there is a fire hydrant, right? Let's say you think, okay, there's a fire hydrant. What does that mean to you?
There's a fire.
Exactly. So do you see that you hearing that siren, your sensation was basically fire hydrant. What perception was, you think, okay, somebody's house, somebody's building, something is on fire. Does that make sense? Now, receptors. Within the sensory system, the receptors are dendrites. Okay, dendrites are the receptors. Okay. Now, in the first week, we explained what a receptor was, right? Receptor is where something binds and it causes a change to the interior of the cell. We have different types. So basically, dendrites, stimuli, which causes greater potential to occur, which basically impulse generated within the sensory neuron. That is the purpose, because when something binds to that receptor, it is a stimuli that actually binds, which causes a change, okay, to occur inside the cell. This is why greater potential occurs. When greater potential occurs, if you reach threshold, then basically you have actual potential, correct? Receptors in the sensory system can be classified based on 5 different stimuli. So anything will come with number 1. Let's talk about number 2 first. Anytime, let's say right now you walk out and it's like, oh my God, it's so hot, okay? So what receptors picked up that information? Changes in temperature. Could be cold, could be hot. Thermoreceptors. Thermoreceptors detect changes in temperature. So something is hot, something is cold, something's warm. Let's go to number 4. Chemicals in nearby areas. So you walk into the restaurant and you basically smell fresh bread, right? Basically, there are chemicals that stimulate certain receptors. So what is a receptor called that responds to chemicals? Huh? What is a receptor called that gets activated due to chemicals? Chemoreceptors. So chemoreceptors basically get activated or stimulated due to chemicals. Okay? Thermoreceptors get activated due to changes in temperature. How about light? What receptors get activated due to light, photoreceptors. Basically, sound waves, pressure waves, touch. If I pinch somebody, if I, slap someone, okay, or if I put a vibrating tuning fork, okay. Basically, what receptors detect that change, that pressure? Mechanoreceptors. Okay? Now the last one we have is tissue damage, excessive pressure, temperature. Okay? So when you have excessive pressure, when you have excessive temperature, basically that causes a tissue to be damaged, and then the tissue releases chemicals, okay, certain specific chemicals, and they go and activate certain receptors. What are those receptors called, which are activated due to tissue damage? Pain receptors. Okay? So there are 5 classes: mechanoreceptors, pain receptors, thermoreceptors, photoreceptors, and chemoreceptors. Now, let's talk about interpretation. The CNS distinguishes sensations. It can distinguish images from light because impulse is generated or sent to specific brain areas, right? Vision is sent to the occipital lobe, correct? Where is hearing sent? To the temporal. So that's what it means, okay? How would you know if I'm yelling at you or if I'm whispering to you? Number of receptors activated. So basically, if I'm whispering to you, let's say that only 50 receptors get activated. But if I'm yelling, 500 receptors get activated. Okay, so the number of receptors gets activated tells you basically the strength of the stimulus, right? And frequency of impulse generated. So how many action potentials? Again, if I'm just whispering to you, maybe only 5 action potentials get created in 1 minute. But if I'm yelling at you, maybe 5,000 gets activated. Does that make sense? In that same amount of time. So as you increase the strength of the stimulus, number of receptors activated and the number of action potentials created per unit time both increase. Does that make sense? Right? Now, this slide, so we have somatic sensation and we have special senses. Somatic sensations, temperature, touch, pressure, vibration, pain, awareness, and body movements to its position. Now, I'm not going to talk about somatic in this chapter, or we just don't have time. So, all I want you to know, which of the following classify as somatic. Okay? I could give you 4 of this, 1 of this, and you have to figure out which one is somatic. Or I could give you 4 of these, 1 of this, which one is special senses. Does that make sense? So for somatic, this is all you have to know. Now, we're actually going to talk about the special senses. Okay? Special senses, there's 5: taste, smell, hearing, balance, and vision. Those are the special senses, and we're going to talk about each of them. Let's talk a little bit about thermoreceptors. Thermoreceptors are located in 2 areas. One is your skin, another one is your internal organs. In the skin, it's located to the superficially, okay, dermis to epidermis level. Now, when it's located within the skin, its function is to detect or monitor the external environment, right? So if I walk out right now, all of a sudden, like it was nice and sunny, now I come out and it's freezing. It's my thermoreceptors within my skin that get activated, okay? Where the receptors located within the internal organs, they're there to monitor your core temperature. So if I have a fever, it's my internal thermoreceptors that get activated, not your skin one. Does that make sense? Which one do you think adapts fast? So, skin. Why?
Because you can either like, if you're like really hot, you'll secrete like sweat.
Okay, I understand reasoning, but the reason why don't hold temperature, okay, have you ever been in, you jumped in a pool and 5 minutes later, once you jumped in, it was freezing, and then 5 minutes later, the pool is warm? Do you think the water actually got warm?
No.
No. Your receptors adapted. It's, what does it mean? It does not respond to the stimuli anymore. Okay? The temperature was the same, but because you were immersed in it, it basically, you would say, went to sleep. It does not detect it anymore. Unless you come out and jump back in, yes. Okay? Then you will feel it. But what happens if you jump in, you stay there for 10, 15 minutes, and it's nice and warm now. You come out, and in that split second, you jump back in. You don't feel that much cold because your receptors haven't had the time to basically, let's say, wake up. But let's say you jumped in, it was cold, you were there 15 minutes, came out, you had something to eat. 15 minutes later, you jump back in, it was cold. Yes.
When you say they adapted, they're not activated anymore, or they're still activated?
They don't get activated again.
It's like a one-time.
It's like saying, okay, I come in and I open the door, okay? I leave the door open. So am I closing and opening the door? Is the student opening the door again? No, it's just open. Does that make sense? So it doesn't mean that the receptors remain open. It's just they don't respond to the stimulus anymore. They're down-regulated. Okay? Now, the reason internal organs or receptors found within the internal organs, they don't adapt because a fever is dangerous, right? So if they tend to adapt, then basically it's not beneficial. It's there to warn you, okay, there's something wrong, you need to take care of it, because it will start causing chaos. Okay, does that make sense? Okay, so they adapt slowly. Now let's talk a little bit about pain receptors. Pain is essential to survival. Why? Okay, why do you need pain receptors? Because it warns you against certain stimuli. Okay, I was, multiple times I've run out barefoot after my dogs. Okay, because they're bullies and they tend to, they're really obvious. I have to keep them inside. So now I have to make sure that they don't escape, and when they do, I'm like running behind them because they will chase everybody down the street. Until that person does not leave the street, they will like bark at them. And they've gotten fights with pit bulls. The day I had interview over here, 7 o'clock in the morning, my 2 puppy dogs got in a fight with a pit bull. Dachshund. One is a dachshund and a terrier, and another is terrier and a chihuahua. Terrier and a poodle. Yeah. So they're pretty small. Okay, they're only like 2 to 3 years old, but they decided to get a fight with a pit bull. So then I was like running around trying to grab them. Then my sister actually had to jump on the pit bull so I could grab both of them. Anyway, but the point is, I'm usually, was running bare feet, and then like multiple times I got hurt. And now I'm like, even if they're running around, like I'm gonna go get my shoes, okay? Because then I basically get injured and I'm like limping half of the time. Anyway, so the point is it warns you against injury, so you won't do that in the future. Diabetic patients, okay, one of the complications is that their nerves don't work, the peripheral nerves, okay? Usually the hands and the feet. And they don't tend to realize that they're injured themselves unless they look down. So they might be cooking, and if she's cooking watching TV, if she chops a finger, she won't know it unless she looks down because the pain is not being perceived. Okay? So anyway, warns certain stimuli, informs you, okay, so you avoid it. Now there are 2 types of pain, fast pain and slow pain. Fast pain is also called sharp or acute pain, and slow pain is also called deferred pain. Fast pain is 10th of a second after the stimulus, okay, because the receptors are near the body surface. So if I step on a nail, that's a fast pain. Okay? is due to excessive physical pressure heat, okay, stepping on a nail, hand on a burner. Slow pain is referred. It occurs seconds to minutes after the injury has occurred because that tissue releases chemicals. Those chemicals will diffuse through the nearby receptors and then activate them, okay? Because the receptors are within the internal organs. So when you have a heart attack, what is a classic sign symptoms a patient will say? Huh? Left arm is going, okay, my jaw is hurting, is radiating down. The reason is because the nerve is, that one nerve is sending branches out. And because it stimulates that one nerve, that chemical is perceived in all of its branches. This is why basically the heart is here, but you feel the pain going down the left arm all the way to the left ring finger. This is another reason why the wedding ring engagement ring is worn on the left ring finger, because that nerve is actually have a branch that goes straight to the heart. So that nerve splits. One branch is gone to the heart, another one goes to the ring finger. Okay? As I said, injury, tissue damage, chemicals released, and pain receptors activated that you have pain. So right here you could see that where everything overlaps. It's not in one distinct area. Fast pain tends to be right where you got injured. But before pain, the pain is felt in nearby areas. Slow pain, basically there is no adaptation, which is beneficial. It allows you to avoid stimuli. Inconvenient is if you have chronic illness, you're constantly in pain. Okay, somebody who has cancer, somebody who has something, they're just constantly in pain because they don't adapt. Now we're going to talk about smell. This photo is complicated, so make sure you pay attention. This one I'll repeat multiple times. Okay. E, I'm going to start with E first. Okay, before I start, do you see, let's just see, do you see here is one, don't write anything, just listen to me. Here's one cell body, okay? Second cell body. In the cell body, these little structures are the dendrites. Does that make sense? Here's a cell body, these are the dendrites, and the cell body gives off axons. Multiple cell bodies come together forming one axon, and the axon goes through, and now here's another cell. Okay? Now, because this axon basically has multiple parts. It has cell body, it has a dendrite, and it has the main axon body. Okay? So what we're going to say, E, okay, this whole entire cell, so C. C is olfactory receptor cell. Olfactory receptor cell. So basically we're looking at the nasal cavity, the nose, and we are enlarging it. So right here is basically the epithelium and everything, and we're just enlarging it. So we're looking at the structure. So C, and C I'm pointing to the entire thing, okay? This whole thing. Now it has parts. It has cell body, axons, and dendrites. Okay? So in the image, it's only pointing to this part, which is the axon part, but please understand, this is olfactory receptor cell, this is the entire cell. Does that make sense? Okay. I'll come back to the synapse bit. E. E is actually the hair cells. The dendrites are actually called hair cells. So E is hair cells, and it's part of olfactory receptor cell. Does that make sense? So it's hair cells, it's part of olfactory receptor cells, because these are, okay, the hair cells. Now, in the sensory system, anytime you hear hair cell, they're actually receptors. And what did I say? In the sensory system, receptors, what is the composition of the receptor? It's a dendrite, right? Does that make sense? So the hair cells are actually receptors. Either it could be mechanoreceptor, it could be chemoreceptor, it could be photoreceptor. And what is the composition of receptors? All receptors are dendrites. Does that make sense? So hair cell is part of olfactory receptor cell. It's actually the dendrites. Okay? They're actually chemoreceptors. Okay? These hair cells are chemoreceptors. What do they detect? Chemicals. Now, D is olfactory glands. They're olfactory glands. These olfactory glands secrete mucus. Why do they secrete mucus? What is the importance of the mucus? Yes. One thing it has to function. One is because you're breathing, right? So that as the air is coming in, the mucus is there to trap any foreign particles that should not go in. So it kind of cleans, filters the air. Okay? That's one thing. Second thing, it also binds to chemicals within the odors. Therefore, the more action potential can start occurring. Does that make sense? Another function is the mucus actually tends to keep these hair cells lubricated. Does that make sense? So what is the function of mucus? It traps something. It traps foreign particles so they don't enter the lungs. Second thing, they bind chemicals which will activate the chemoreceptors, the hair cells. And third, it actually lubricates the hair cells. F is the odor. F is the odor. Now, B is this entire structure. Not what's contained, but just what is this entire structure. Okay? Which is the olfactory. Did you already do the brain in the lab? No. Are you guys doing it this week? The olfactory bulb. Olfactory bulb. And you're responsible to identify the olfactory bulb when you look at the brain. So B is this entire structure. This is the nasal bone. Okay? But you don't need to know, but I'm just trying to show you. Now you're inside the brain. This part is the nose. Now you're going through the, basically, the part of the bone. Okay, it's part of the cranium, okay, but that allows nerves and everything to go up and enter the brain. So now you're within the brain, and this section of the brain is called, B is olfactory bulb, okay? Within the olfactory bulb, okay, within that tissue, you could see this olfactory receptor cell is basically synapsing with another neuron right here, right? What does a synapse mean? A neuron and a neuron, right? Or a neuron and something else. This one is a neuron and another neuron. Here's the cell body. This is the axon terminal. So axon terminal synapses with the cell body of another neuron. Okay? So location is the brain. So this I still have to answer for you guys, and this I have to answer for you guys, which I'll come back to that. A, which is this cell right here. So you could see the cell body and the axons, the cell body and the axons coming through. Okay? A is olfactory neurons.